Hey everybody, how you doing today? Happy Thursday. Sorry, I got started a little late here today. Things were a little crazy with some meetings earlier today. So we're going to finish up talking about variables and expressions here from Chapter 2 in the zyBooks. Let me fire up PyCharm. We got through most of the content kind of quickly, so we're going to go through a couple more highlights and try and practice a little bit more of this today. And then come Monday, right, on 9/20, we'll have our lab for Chapter 2 activities, and then we'll pick up our next types in Chapter 3 next week, and then we'll look at our first individual project next week. Once we've covered those first 3 chapters, we've got a little bit more going on that we can actually play with to have a little bit of fun for our first project. So next week we'll look at that first project coming out. Let's see if I can get PyCharm going here. I forgot to refill my coffee cup. That's really sad. Been stuck at my desk all day. All right, looks like we got a lot of the labs in, which is awesome. So if you had any trouble with that, do let me know. Happy to chat about Lab 0. And again, the Chapter 1 quiz got posted late. Apologize. Usually they'll be posted on Thursdays after we finish the topic. So today I'm going to leave myself a note to post the Chapter 2 quiz. I can post that afterwards. Again, there are 10 questions. It's open book, open notes. Take your time. You know, open it up, close it out, open it, close it out. As long as you get it in by the due date, we're good. And then we can just kind of follow. We'll do one quiz per chapter as we go. When we get to those couple weeks where it's we'll double up on chapters, it'll probably just be a single quiz for the whole week, because the chapters are a little bit small, because we can cover like modules and exceptions all in a single week. We don't need a quiz on each of those. So maybe we'll just call them weekly quizzes. And then for inheritance and recursion, we'll probably just do one quiz. And we won't even have a quiz when it comes to plotting and basic graphs. Our graphics, because that's like the last week of the semester, and then we're just getting ready for the final project. So I don't think we'll need a quiz on that. So,
Can you print one of the pages in my dreams?
of what?
In my dreams.
That a song?
Yeah.
After this. Okay. All right. Cool. So we got PyCharm here. Awesome. So we worked through some of the basics, looking at some examples, some different basic types, or numeric types, characters, and this ordinal value, right? Behind the scenes, individual characters are stored as their numeric values, so we can get out individual letters or convert them, do that sorts of fun stuff as well. Let's see. Where did that? There it went. And again, real big on this order of operations. It's not difficult, but you know, it takes a little bit of time. And then modulus is super cool, being able to do this remainder here. So there's this really fun. Okay, I think it's fun. You guys might disagree, but that's okay. The thing that you can do with numbers. So if you ask the user to enter a number, right? If we want to say, hey, will you enter a number for me? We can do some kind of cool arithmetic with it. You know, we haven't even got to that yet, have we? We have not. No, we have. So when the program runs and we want to ask the user to type something in, right? We use input. So if I say, hey, input, it's parentheses, enter a number. And we'll say 1 to 9 for right now. 1 to 9. Now we need a place to store what they're going to be typing. Right, so we're going to say, okay, well, really, I want to save this as your number. So say your number is equal to, or we're going to assign, so that's probably a little small, isn't it? Let me zoom in a little bit more. We'll say your number is equal to, or we're going to assign whatever we get here on the right to this variable here on the left. Now, if we want to deal with arithmetic, right, we need to make sure that this number is going to be treated as an int. So we'll say, hey, int of this input will be your number. Okay, then what we want to do is we want to take that number and we want to multiply it. So I'll say like the result is equal to your number times 9. So if you multiply your number times 9, we can do some fun stuff with it. Now, the magic trick goes, what you want to do is you want to take the value of the tens place. So how do we figure out what the tens place is? Well, we can do the tens place is going to be the result divided by 10 with this integer division. Right? This means throw away the decimal place. All I want is an integer here. So this is divided by 10 will tell me how many tens, or what is the value of the tens place. And I can get the ones place. Wait, we didn't do this before yet. Okay, good. Then my ones place can be the result modulus 10. Remember, modulus will give me the whole integer remainder of dividing by 10. So it'll give me the ones place. So then I can say your number, let's just print this. We'll say your number times 9 is, and then we'll just add in here the result. Right, so that's what the result is. And then we say the sum of the digits in that is, and we can add in here the tens place plus the ones place. Do you guys know what that the sum of the digits is going to be? This is the magic part of this math. Let's give this a run. So for any number that we enter here, a 1 through 9. Actually, it can even be 1 through 10. Let's do 1 through 10. 1 through 10 will work. So enter a number, a 1 through 10. So somebody there in chat, shout out a number 1 through 10 for me. See what you get. This is the audience participation part. I think I'm online. Anybody around? Yeah, we got a couple people around. Maybe Nightbot will answer for me. Any number 1 to 9, or 1 to 10. I'll just drink my coffee here. It is empty. It's sad. Yeah, all my coffee's empty. All right, no one wants to play. That's fine. Let's try 7. So 7 times 9 is 63. The sum of the digits in that is 9, right? The tens place is 6. The ones place is 3. So no matter what number you give it, we're always going to get 9 back out, which is really cool. And this even works with 3-digit numbers. It just gets to be a little bit trickier. So we can do that as well. So if we say enter a number 1 to 100, we can do the same thing, but now we need to get the hundreds place. Hundreds place is going to be the result floor divided by, or integer division divided by 100, right? How many hundreds are there? Now, this one we actually don't want anymore. We can't just figure out if we divide it by 10, what's the result here? Right, that's no good. So to find out the tens place, right, we want to divide out all the hundreds first. So we want the result modulus 100 will give me what's left over after I divided out the hundreds, then integer division by 10. Right, so this gets rid of the hundreds, then will give me the tens place. And for the ones place, sure, it's just whatever's left over when we divide by 10. Right, whatever remainder there. So now we can add in the hundreds place, and it's okay if it's not a 3-digit number. If I picked 1 and all I get is 9, I'm going to get 0 hundreds, 0 tens, and 9 ones. 0 plus 9 is 9. Right, so let's give that a try. Run that. All right, so let's pick a number. Let's do like 57. So 513. 5 plus 1 plus 3 is 9. It's pretty cool. It'll work for any of them. And actually, you can do this all the way through. Anytime you multiply by 9, the sum of the digits will equal 9, which is kind of cool. Now, eventually, you're going to get too large, though. And so the sum of the digits then is going to be either a multiple of 9, or you can say, hey, let's redo that again, take the sum of the digits, and then add them up. Take the sum of the digits, add them up, and then that result would add up to 9. Right, so 513 adds up nice. If we go larger here, let's do something larger. Can we do 87? Oh, I'm sorry, no. Like if we do times a 3-digit number, let's do like 357. We're going to get 3213 for our result here. Actually, when those ones added up, it does add up to 9. All right, this one wasn't large enough. We got to pick a bigger one. Let's do the bigger one. Let's do like 876. There we go. So 7884. So if we add these ones up, 7 plus 8, sorry, I can zoom that in a little. 7 plus 8 is 15, plus 8 is 23, plus 4 is 27. So then that result is 27. If you add up the digits of 27, you'll get 9. And so it's always going to be a multiple of 9. Figuring out how large it is and how many digits we have to take out, that takes a little bit more work. But that's okay. Right, so we can see anytime you multiply by 9, you can do some magic here. And we're just kind of practicing some of these arithmetic operations, right? The integer division, modulus to give me the remainder, more integer division, regular arithmetic. We can do all sorts of fun things here. And if we're actually asking the user to enter a value, that gets to be more fun. All right, so let's do another one here. Let's say we want the user to, let's add up a couple of values here. So let's say I want to have a sum is just going to start off at 0, and then I'm going to ask them to enter a bunch of values. So I'm going to say sum plus equals, right? This is my shortcut for add and then assign back. Or I could say sum equals sum plus something, right? The same way, that's just slower. Right, so sum plus equals, that's my combined assignment operator, the int of an input. And we'll say enter a number. Right, and we'll do this a couple times. So maybe we'll enter 5 numbers. Right, so then I can print the total is, and then we can add in the sum. How about the average? Can we figure out the average? Right, well, that's going to be sum divided by 5, right? Because we entered 5 numbers. Right, actually, we can even start sum. So you can't use plus equals if you don't already have a value. So up here I said sum equals 0. Great. If you wanted to, we could just say, hey, sum equals that, and I could get rid of that line. But then they don't all match, and I don't know. So it's just a style preference. They're both going to do the same thing. One, I start sum at 0 and I add to it. One, it just starts as the first value. Shouldn't matter much. So let's try it. So we'll add five values together. All right, so let's do, how about 10, 20, 30, 40, and 50. Our average should be 30. Yeah, 150 divided by 5. Worked out to a nice 30 here. All right, so we got some options here when we're doing all of the arithmetic, right, depending on what we want to do. Right, and Python's real powerful, can handle lots of this. Let's see, let me go through an option there. Yep, operators. Awesome. Deal with our characters. All right, now here's kind of a fun thing. So we can get individual characters out if we want here. So if we ask the user, let's say, we'll say first letter is going to equal an input of, please enter your first initial, right? And then we'll have our first initial, how about that, first initial. And then we'll do their middle initial and their last initial, right? So first, middle, and last. First, middle, and last. Now, by default, integers are going to give us strings. So if I want to treat that as a character, I can say, hey, treat this as a character, please. This is CHR for character. Okay, it's going to convert into a single character because we want to deal with some numeric values here in a second. We're going to have a little bit of fun with it. So then I should be able to print the first initial, middle initial, and the last initial. Right, dealing with individual characters should be fine. Let's see what we get here. All right, so a number, bunch of numbers, and then E. Oh shoot, nope. That's right. You can't do a character that direction. Sorry, that works for numeric values. I just want the first one. Well, that's not going to work, right? All right, let's do. That's a bummer. We haven't talked about any of those yet, have we? All right, I'll just put it in. I'll just put it in here. So I'll just say, hey, it is E. Oh, shoot. Let's try this. We'll try, instead of a character, see if we can do an ordinal. There we go. We'll take that as the ordinal value here. See if we can get those ordinal values back out. Right, we did those before, just trying to build individual characters out. We're checking the ordinal values here. There we go, E, T, and C, and I get their numeric values. But now what I can do, right, I can take those, and I can kind of shift them a little bit. Right, say, and we want to move them along. Let's pick like the next letter in the alphabet. So I'm going to take first initial +1. I'll take middle initial +1, and I'll take last initial +1. So if I want to print out the letters, right, I will turn them back into characters. Here we go. So we can change it from characters to ordinals to characters. So we're going to shift them all one, and then we'll move them. So we can change their initials. And so by adding one, it's going to move it to the next letter in the alphabet here. So E, T, and C get moved to F, U, and D. Right? Those are the letters that come after these. So you can just kind of move one letter at a time. Now, once we talk more about strings later, there's ways to do it on an entire string. Kind of fun. So this is not encryption at all. That's definitely the wrong word for it here. But it's just it's applying a little cipher here for fun, just kind of moving them one direction. And we could go forwards, we could go backwards, we could go by 5s, by 10s. You know, we got all sorts of options here to do that. It's just kind of fun. So why don't we ask them? Here, let's say, hey, how far? So we'll have an int for the number of letters to shift by is an int of an input of how many letters should we shift by? Okay, and we'll take that and we'll add that to each of these. Now the problem is, or if you get too far off that Unicode table, you get into things that aren't letters anymore. So not worth remembering, but 65 is an A. So 65 plus 26 is going to put me at, what's 80, 94. So we want to check to see if we went above 94, we want to subtract. If it's greater than 94, we went too far, but we don't know how to check that yet. That's okay. We'll just get some weird, we can get some weird characters maybe. We'll learn that next week. All right, so E, T, and C. And if I shift by 10, you're like, see the T turns into something super weird. It'd be nice to have it wrapped back around, but it's okay. We haven't got there yet. So we can see we can shift by a variable amount here by asking the user how far we should shift. It's kind of fun. We can translate letters one to another. Do some sort of encoding, right? Not encryption, but encoding. I'm pretty sure it's the wrong technical term for it. Let's define encryption. Oh, okay. So it's just a bad encryption, I guess. So a very, very simple cipher. So I think it was Caesar had a common one. Right? Caesar cipher. Look at that. Crypty.com. I don't know. Let's see. There's probably like a Wikipedia here that's better. Yeah, okay, this is the basic one. It moves by 7 letters here. Look at that. That's a cute little website. Maintains the case, ignores foreign characters. Notice this one is keeping the spaces in it, which is makes things a little bit easier to decode here when you're looking at ciphertext. If you can say, hey, you know, this must be a 2-letter word, this must be a 2-letter word, this must be a 2-letter word. There's only so many 2-letter words. You can start kind of applying some of these backwards. We can play with some of that later once we learn a little bit more. Right. Other questions, other thoughts, concerns about Chapter 2? Again, still we're starting off a little bit slow. Just trying to practice, hey, these are the different types that I can use. These are some basic expressions that I can use, some arithmetic expressions that really they work on numeric values. Yeah, you can do it by characters, and that's kind of fun too. But strings, right, when we're dealing with string input or string values, we're limited in what we can do for now. We'll learn more about that as we go. We'll get into a couple of basics next week on strings. We'll have some fun with those. All right, cool. So that's actually it for today. We got through a lot of it on Tuesday. The chapters do get a little bit longer. You know, we start off a little bit slow here. So most weeks will probably take up more of our time here as well. And then we'll also have time to ask questions about the project. So again, we haven't really done enough to have an actual project yet. Once we've gotten through next week, we'll have enough under our belts to start our first major project. Again, the idea with the labs is you get them done in the sitting time. When we're in lab, or if you're remote, that's fine. With the projects, it's you need to apply all that information, and it should take a decent amount of time. They're not going to take you dozens of hours or anything, but it should be a more significant assignment than a quick little lab. Is kind of the expectation for that. So let me know. We'll see you in lab on Monday, and then Tuesday, Thursday online here again, and we'll talk about the first project, and we'll just keep on cruising our way through. We've got, we're only in week 3 here, wrapping up week 3, but week 1 didn't really count. We didn't do a whole lot there. So really 2 weeks worth of Python. Definitely you want to get familiar with GitHub and that workflow with your GitHub repositories. We're going to do 1 per lab, 1 per project. And so every time we're going to have to clone the repository, put our code in it, and it'll be good to go. So let me go commit this code here. So I'm using the same repository every time so that you only have a single link to go look for course examples. I think that'll make life easier. But for all your projects and assignments, keeping them separate is going to make life easier for me. At least I can find them all separately. So we grab this here, and it should say, hey, this Chapter 2 Python file, main file here, has been updated. See, it's in orange. There's a bunch of new stuff that was added. I didn't change anything up above, so not a whole lot of differences there. So here's more Chapter 2 fun. I'll commit and push, and you can go view this repository online anytime. I got the link there in Canvas, or it's on my main GitHub page if you're curious and want to see that. Let's see. And sorry for the late start. It should be relatively rare. Just ran into a couple things today, so if you have any questions, let me know. If not, you folks take care, and I'll see you around on Monday. Thanks, everybody.